So today's video was kind of a follow-up to the IBM ThinkPad restoration. But anyway, the whole point of this video is actually twofold. One is, so when I was restoring the IBM ThinkPad, I needed to get the original recovery software. Found that online, fortunately. However, it doesn't boot, so you need a special boot floppy in order to be able to run the installation and recovery and everything. And I realized that I didn't have any machines with working floppy disk drives in which I could actually transfer software to and create the disk from, because my only machine that I have currently working is the NEC Ready, and that's got a GoTech in it. So I figured, all right, no big deal. I'll just grab the original floppy drive, throw it in one of these little 3.5 inch to 5.25 inch trays, slap it in the case over here, and no problem, right? Well, not exactly. So when I originally did this, I went and I was going to go and install it and everything properly. Got myself a ribbon cable with multiple connections on it so that I could connect the GoTech and the floppy disk drive at the same time. Went to go slide it in. And, well, this thing needs drive rails, and I didn't realize that. And I don't remember having a secondary 5.25 inch disc when I originally had this machine back when I was a teenager. So I didn't remember that. So I figured I'd take a look around, see if there's any rails built in or anything. Because some cases, some OEMs will just kind of attach them like inside, or maybe just include them as a kit. This did not come with any, and I did not see anything attached. So more than likely, there's no rails for this thing. So for that project, I just went and had this kind of sitting off to the side. But I realized that I want something more permanent. And so I went and found some of these generic rails that I had sitting around. And, they'll work. When I had them attached, to actually slide in and keep everything secured, except for the fact that on this particular chassis here, you have to have the rails to secure to the front. That's what these screws are for over here. And these don't. So they're basically like L-shaped brackets, right? That's a problem. I tried looking online to see if I could buy some. All of them, all of the generic ones anyway, kind of look like this one. So the only option was I can either cut up some sheet metal, probably spend about 10, 20 minutes doing it and be done with it, right? But we like to do things the hard way here. And so I figured, why don't I try to 3D print some? I went online to see if anyone had already created some models. Could not find anything. So that means I have to learn how to 3D model. And that did not go well. It was a long, tedious process, probably several hours over several days, just to create something as simple as a drive rail. But I did eventually come up with something, and took me a few tries until I got it right. So, and while this is not going to be like a tutorial on how to do this type of stuff, because you do not want to learn 3D modeling from me or printing or anything like that. There's plenty of tutorials online for that. This is just kind of going over what I had to go through to get it to go and get it to work and everything. So let's go ahead and I'll go over the basic process. And we'll fit the final, hopefully the final rails into this drive, see if it mounts, and get everything connected. So the process itself, you would think it's simple. You just, draw an L-shaped bracket, poke some holes in it, make it from 2D to 3D. It's what they call extruding. And then that's it, right? And I thought that might be that easy, but it's not. It's not as simple as just taking a two-dimensional picture and making it 3D. It kind of is, but it's a little bit more involved than that. Especially since you have to have measurements that are pretty accurate. You can't just guess. You can't look at it. It's like, it's about 5 inches, no problem. And that's it. So I went and I started by taking some cardboard and measuring things out and just kind of poking holes where they should be, folding and making sure that everything works correctly. And then taking rough measurements from this, translating it into, in this case, FreeCAD, because, it's free. And it seems to be relatively easy to use, lots of tutorials online and everything. So I figured I'd start with that and work my way up, right? So I went ahead and created a basic shape. I used some tutorials just to learn how to even do that because it's not that intuitive. You really need to know what you're doing to use software like that, even for something this simple. Although if I had known what I was doing, it probably would have taken me 5 minutes to design something, another 10 to 20 minutes to print it out, depending on settings and things like that. And would have been good to go instead of multiple hours over multiple days. But eventually I came up with this little design here. It's about 1 millimeter thick, very flimsy, but it would do the job. problem is when I went ahead and tried to get everything lined up, they're close, but not perfect. Now, I only need 2 of them. So for my needs, this would have been good enough. But the other issue that I ran into, well, 2 other issues. One is that this did not extend far enough over the screw mounts in the case, as well as the fact that it's a millimeter thick, however you want to describe it. And if you take a look at the chassis again, there's this little ledge-like thing that it has to sit on, and it very, very just barely did. And my concern was when I get the other side attached, is that can extend far enough over? And we'll get to the other side in a bit because that's a little bit of a different story. So I figured let me thicken it up a little bit, and it gives me an opportunity to adjust these holes, these mounting holes, and we can go from there. And yes, I could have just printed out a basic, L-shaped bracket, drilled the holes, and saved myself some time. But again, I like to do things the hard way. So next iteration was this one. And you notice it's a little bit different. I got it kind of rounded, tapered at the end here. And I made this about 3 millimeters thick. Kept this at about 2. If it would focus here. Does not want to focus. Focus, damn you. Why won't you focus? There we go. So 2 millimeters here, 3 here, rounded off the corners here. And I decided to go for more of an oval shape here, as opposed to just screw holes. Because I also realized that, at least in my history of working on computers, mounting holes are never, ever in the same spot from drive to drive to drive. It's like the specifications that exist are more suggestions than not. So I figured I'll keep these static, and then these can be adjustable. And that way they would work with not just this particular bracket here, but possibly other optical drives and things like that. And the one picture that I found of the drive rails, it's not exactly the highest quality one, and the drive rails are already kind of mounted onto the drive at an angle, and there were multiple different mounting holes that they included on there. Not exactly a detailed enough photo for someone like me to be able to recreate it. Maybe someone with more skills could do it. But I figured this should apply to just about most scenarios, and if it really became a problem, I could just end up drilling holes anyway. Again, for this, it'd be more than enough. So anyway, went ahead, printed it out. And if I could get it even there, they align. I don't know if it shows up on camera because the focus just does not want to cooperate today. But they did line up. So as you can see there, all of them line up close enough anyway. I did fine tune them a little bit as we continue to go on. But again, I only really needed the 2. And so I figured good enough for now. I can always fine tune it later. But again, this part was the problem here. It did not want to line up with the mounting hole, even though I made this thicker and everything. So my next design, I went and adjusted it. I also adjusted the mounting holes a little bit more, moved it a little bit more over. I made this a little bit thinner. I went down to 2 millimeters, thinking maybe it's because of the fact that it's 3 millimeters. It's throwing the bracket off here. Still no dice, but the holes are as close to perfect as I am able to get them. So we'll throw that to the side. I changed the design a little bit further and decided to go with like an oval shape mount, because I also realized that, well, if the mounting holes, on the sides aren't necessarily going to be correct, it's entirely possible that the overall width of an optical drive, this bracket, whatever, they might vary ever so slightly. So if I do something like that, I'll be able to slide it, adjust it, and everything. And this was almost perfect. You may notice that it's not exactly centered. It's a little bit lower. Yeah, I don't know when I did that. I must have accidentally bumped it just before saving and exporting it to an STL file. It almost worked. And again, had I maybe just drilled a little bit up here, would have been fine. Yeah, but I didn't want to do that. So I went ahead and edited one more. And again, it was just a simple fix to make. Simple after I struggled, but there's basically the final one right there. It's centered and it does line up. Let me just go ahead and re-loosen this screw here. And I mean, I know the camera angle is not exactly the best, but it works. And then there's a little bit of give this way. So now you're thinking the left one should be a breeze. You just have to flip it over and that's it. Print one of these and that's it. If you notice the way the mounts are, they're closer to the bottom than they are the top. So flipping it around would not work. So what I ended up doing is basically just taking this piece, moving it to the other side, and, came up with this. Now you might notice that this particular oval shaped hole is not cut off compared to this one here. And that just has to do with the fact that when I extruded this side, I went from 0 all the way up to, 2 millimeters, whereas this one here, for all intents and purposes, started at -0. I know that doesn't exist, but it went into the negative direction on the x-axis, or is this the y-axis? I don't know. Three-dimensional space kind of confuses me. But that's why that's like that, because technically this piece here would be right about there. But whatever, it still works. Plus it gives me a little bit more of a give, because on this side here, let me see if I can get a better angle here. So if you look on this side here, there's this little protrusion that comes out. Not sure why it's not just a mirror of that, but it's not. And so it kind of sticks out further. So having this like that gives me a little bit more leeway. Because if we go back to one of the earlier models, just to give you an example, there's no way it would have even secured itself to the case. And even if we went with one of the later revisions, even though this one was off-center, it still just barely hit the edge there. So I'm hoping, again, a little bit of leeway that way. So it's a little bit more universal. All right, let me change this angle back again. Actually, no, we'll keep this angle because we're going to see if everything works. All right, let's see. I'd say that's pretty good. Yeah, it's not moving. That's good to go. Now, let's go ahead and put this front cover back on, make sure everything actually fits. Yeah, there we go. Sticks out a tiny bit, but so does the CD-ROM drive, and that is actually mounted directly to the chassis. So like I said, I'm going to consider it to be just kind of like a quirk. I could still adjust the mounting holes. Let me grab the almost finished one here. I suppose I could take these and push them forward just a tiny bit, maybe a millimeter or so, and it would be fine. Actually, what I may end up doing is the same thing I did here, is just making these ovals and keeping it that. Maybe I will reduce this down to maybe 1.5 millimeters as well, and try to, give this the best chance of being as flush as possible. So this was fun, especially after printing, multiple different variations and revisions of it, getting down to pretty much near the final one here. But because it's not completely finalized yet, I'm not going to publish the STLs just yet. I will probably either do a follow-up post with that. Okay, so Future Koz here. I went ahead and I designed a new bracket, a little bit shorter, slimmer, however you want to consider it. Kind of based off of this one. I did not taper off the end here. I'm still trying to figure out how to get that to work. Every time I try, it keeps telling me something's not connected, whatever. But of course, I goofed up on this part here because this isn't high enough to match where the actual screw mount is. So I modified it and added that. So that will be the right one. There will also be one for the left, which, basically is just reversed with this part shifted upward. So I will release the STLs for that, as well as the, my original design there. So I'll have links down below, so that if you guys have this particular style of chassis, the 7610, I believe there was a 7022, a 9022. I think almost any NEC system from like 95 through like 99, even if they had a different front panel on it, the actual chassis itself was very similar, if not identical. So, all right, let's move on to the next part of this video. So the next part of the problem, so here's the 34-pin connector. The drive is all the way back here. It does not reach. Now, I could swap the positions of the optical drive and the floppy disk drive and everything. Unfortunately, the way this case is designed is that the other two screws on the other side are clearly on the other side of the optical drive, but they're blocked by the actual motherboard itself. And for me to get to them, I'd have to remove the entire motherboard. I'm not doing that. So instead, just went online, picked up one of these. It's basically just like a little extension. I don't know if it works. I'm hoping it does. But effectively, it's just going to be, straight through pin to pin. So even if it doesn't have a twist, it doesn't need it, because that's built into the ribbon itself. All right, so we should be able to just do this. And then I'll get this plugged in. And as you can see, it's plugged in. I got the power plugged in as well with another Y adapter, because why not? The OEM power supply just doesn't have enough connectors coming out of it, so hopefully that'll just stay in there and nothing will burn down. All right, everything but the actual case cover is back together. Let's go ahead and see if we can get into the BIOS and configure the disk drive. Well, I know we can, but let's do it again anyway. All right, so obviously you can see only the A drive is there, and that's going to be the GoTech, which has power. So we've got to go ahead and set it to that. And I don't know if the microphone picked it up before or not, but let's see when this comes back up again. There's the floppy seek. I just have a basic DOS installed here. There's nothing fancy. I just want to test the drive to make sure it's still working and see if we can copy files to and from it and go from there. No idea if there's anything on this disk. I guess we'll find out. This should be the B drive. Nothing. Cool. That's a good sign. Let's go. Oops. What do I have on here? Wow, just a basic DOS install. Well, let's do this here. Format B:/Q/S. Q is for quick, S is for system transfer, so we can make it bootable. And it's going. There we go. None. No. Now if we go back to the B drive, command.com. Let me make sure the GoTech is still working, which would be the A drive. What disk image is loaded? Yep, good enough. And it's working. That's the disk 3 to MS-DOS 6.22. So seems like the B drive is working. The GoTech on the A drive is still working. Cool. So now I have the ability to actually still mess around with physical floppy disks. Now, why might that be important? I have a GoTech, right? I should be able to copy any floppy disk image to it, and that's it. Well, as I mentioned earlier, the whole reason this whole project started is because I needed to create a boot floppy disk for the ThinkPad to be able to start the recovery process That's what's on this disk right here. So now they do make GoTechs that are slimline that you can use in a laptop, etc. However, they require a little bit more work to get them to functioning on that, as opposed to a desktop GoTech where you just had to solder a few pins on, get into like a bootloader mode, flash a firmware, and that's it. On the slimline ones, I believe you have to remove certain components and things like that. It's a little bit more involved. Plus, they're a little bit pricier. So I didn't want to just buy one and then screw it up. And then, well, there goes $40 or whatever. So having an actual working drive on here will actually help me out a whole lot, especially since I do have the GoTech. And then I can copy floppy images to that and then use that to clone them onto physical disks. And vice versa. If I ever come across some floppy disk that does not have an image out there on your net, I can sit there and then copy it to the GoTech, and then now I have an image. Now, I know there's better ways to do it, more correct ways to do it. I forget the name of the utility and the device itself, but I'm probably not going to ever buy one of those anyway because they're a little bit pricier, and I'm not looking into archiving every single thing I come across. Most of the stuff that I end up collecting are already archived somewhere anyway, but you never know, you might find a random disk here or there. So, and now that my 3D printing skills have gotten a tiny bit better, I can probably finally print out some slot brackets here for the VooDoo Intense 3D and my little USB card here as well, because they're just kind of flopping in the wind, and that's not exactly safe. This doesn't move around a whole lot, but still. Second update, I went ahead and I also created PCI brackets for both the USB controller card here. That actually came with a low profile bracket because I wasn't paying attention. Started off with a template I found online and downloaded it and modified it to work. Of course, there's no mounts on it, so then I came up with this here, which was basically perfect, but the mounts ended up being too thin. I made them 1 millimeter thick. I probably should have done 2. So they're just too flimsy. If I could get this damn thing to focus. There we go. So then I came up with this design here, but what I did is I extended them out further than they were on the original bracket because I wanted the USB ports flush mount with the openings because otherwise they were sticking out. Unfortunately, the card is designed that way because, well, I don't know why. The port mounting is, not in the right spot, so this wouldn't actually fit unless I crammed it in there, and that's why this looks kind of bent. So I modified it so that this was the original length or whatever for the mounts, and now I have that. And I also created a bracket for my VooDoo Rush card since I didn't have one. And other than the composite port not being perfectly aligned, and I guess technically here too, it's close enough, I think this was for 3D glasses, 3D goggles, something like that. The S-Video port's fine, and so is the VGA port. It's not perfect, but I think it's good enough, and it does fit. So, yay, adventures in 3D printing. There's the progress. And then, of course, what's installed. And it started off as just some cardboard cutouts and generic mounts. So what do you guys think? Again, I know these aren't perfect, and I'm still going to fine-tune them, and I won't release them yet until they are good enough, at least. And I will release them in such a way that you'll be able to take them and modify them yourself and everything, so that if you need to tweak them for maybe a slightly different type of case, different type of chassis, or if you need it to be absolutely perfect, you can do that. But I want to make sure that, again, that these are a little bit closer to perfectly fitting before I go ahead and release that. Have you guys had to design anything on your own? What were your challenges? Or was it really easy for you? Let's talk about it below. Otherwise, thanks all. Catch you later.